This will be the second video for the final review of math analysis second semester. Number 10, it says list all the real zeros of the following function. There's my function. First thing I'm going to do to find my zeros, I'm going to factor out my greatest common factor, x, leaving me with x to the fourth minus x cubed minus 3x squared plus 5x minus 2. Now, because 0 is a factor, I'm just going to put a 0 over here in my list. Now, using the rational roots theorem, I know that all my other zeros are going to be plus or minus 1, plus or minus 2, all the factors of that one, divided by all the factors of that one. So we have only a few things to check. So let's check a few using synthetic, because that'd be a good review for you. 1, negative 3, 5, negative 2. And I'm going to check to see if 1 works, because I think it's going to. I get 1, 1 times 1 is 1. I get 0, 0 times 1 is 0. Negative 3, 2, 2, 0. So 1 is going to be in there. And let's try, remember, that's our remainder. So we're going to try one more. Why don't I try 1 again? Now, why do I think that 1 is going to work again? If I add together all my coefficients here, 1, negative 3, and 2, I get 0. That tells me that 1 is going to work. So I'm going to bring my 1 down, multiply, add, multiply, add, multiply, add. So now I'm down to a quadratic, and I want my quadratic is x squared plus x minus 2. And I'm going to factor, and it appears as if this will factor into x plus 2 and x minus 1. And I know that negative 2 and 1 are another factor. Remember, this would be our third. And if you remember, we would say 1 with a multiplicity of 3, because we had 3 factors at that same place. All right, that's a good review of synthetic also. Let's move to number 11. They give us x minus 8 over x squared plus 4x minus 5. We have to factor our denominator to help me find my zeros. Factors would be x plus 5 and x minus 1. So I know my vertical asymptotes are going to be where my denominator is equal to 0 at negative 5 and positive 1. We know our horizontal asymptote is going to be at x equals 0 at y equals 0, because the power on top is less than the power on the bottom. That gives you a horizontal asymptote. Remember the 3 cases where the power on top is less than the power on the bottom, you get y equals 0. If they're the same, you divide the coefficients. And if the power on top is larger than the power on the bottom, then there's no horizontal asymptote. Number 12. Use the change of base formula to calculate log base 7 of 6. My change of base formula says that this would be log base 10. Remember, we don't write base 10 when we do log base 10. Divided by log base 10 of 7. And let me put that into my calculator. I get 0.92. Number 13. Write the equation in logarithmic form of 3 to the x equals 19. In logarithmic form, we would know that this would be log base 3 of 19 equals x. And it just says to write it as a logarithm, doesn't say to solve it. If it did ask me to solve it, I could, using my change of base formula. Number 14 says condense 2 ln of x minus 6 ln of x squared plus 5 plus 2 ln of 3. Remember, the coefficients out front become the exponents on each of these, so I'm going to rewrite it as the ln of x squared minus the ln of x squared plus 5 to the 6th power plus the ln of 3 squared. Now, when you subtract in these ln's, you're going to be dividing, so I'm going to do the ln x squared goes on top. We're subtracting this one, so it goes on the bottom. And we're adding this last one, so that one would go on the top. And just for the fun of it, I'm going to do some simplifying on that. 3 squared is 9. Coefficients usually go in front. So I'm going to rewrite it like that. Number 15. We have 4e to the negative 2x minus 3 equals 17. And we're supposed to solve this, so I'm going to add 3 to both sides. I have 4e to the negative 2x equals 20. Divide by 4. Divide by 4. E to the negative 2x equals 5. Now I want to find out what x is, so I'm going to do the opposite operation of e, which is ln. So I'm going to ln this side and ln that side. E and ln are opposite operations, so they go away, leaving me with 2x equals the ln of 5. Divide by negative 2. Divide by negative 2. My x is going to be equal to ln 5 equals, divide by negative 2 equals negative 0.80. Let's look at number 16. Number 16, they say that the tan of theta is equal to 5/12, and they want us to calculate the cosecant of theta. Well, I'm going to draw my triangle. And I'm going to put my theta there so I can draw my triangle and try and figure out. We know that the triangle is the adjacent, or the opposite over the adjacent, so my opposite would be 5, my adjacent would be 12. I'm going to use the Pythagorean theorem to get my hypotenuse. Some of you may already know what that one is. It's a very common one. I get 169 equals c squared. Square root of that gives me 13. So we know our triangle looks like that. Again, I'm not sure what the cosecant is, but I do know that it's 1 over the sine of theta. So if I want to find out what the sine is the opposite over the hypotenuse. So I'm going to put 5 over 13. And the reciprocal of that would be 13 over 5. Number 17. Find the measure of the angle. This is 4, this is 7, and they tell me this is my angle. And we're going to use some trig. We know this is the adjacent side, this is the hypotenuse, because that's the right angle. So I'm going to say that the adjacent is 4, the hypotenuse is 7. If I'm solving for the angle, I need to use the inverse cosine. Cosine and inverse cosine go away, leaving me with theta equals the inverse cosine of 4/7, which gives me 55.2 degrees. Set this to the nearest degree. Let's go with 55 degrees. All right, let's stop there, and we will pick up in the next video.